Hi everyone. Welcome to lecture 5 of CSCI 100, Intro to Computer Science. You might notice I'm up here in the top right corner now. I think that this might be a better place where I'll block less things. We'll try it out for this lecture and see how it feels. In this lecture, we're going to be covering style, which is a word you're probably already familiar with from everyday use, but probably not familiar with in programming languages. We're also going to talk about control flow and conditionals, which will be new tools to add to your tool belt to solve problems. And finally, we'll talk about some new string functions. So some new ways to use strings that'll, combined with control flow and conditionals, you'll be able to use to solve many more problems. Style. Let me ask you first to think about who reads the code that you write. I have the answers up on the screen here because I can't have you respond in person. I wish I could. But first and foremost, the computer, of course, is reading the code that you write. We write it for the computer. The compiler, in fact, translates the code that you write into binary, which is the language that computers can understand. Of course, you could try to be funny and say, oh, well, you read the code as the writer. I read the code, right, when I'm writing my code. That's actually totally true and totally valid. I'm going to split these two into two different categories there because there's you of today when you're writing the code. So you're writing the code immediately, you just wrote it, you go on to the next line, you look back up to see what you wrote. But there's also you of the future who is probably closer to the category of other people. So you write your code, you submit it. I or one of the TAs looks at the code that you submit, and we fall into this category of other people because we're not you. And future you is also not you. You've gone through a lot of different things. You're already a different person. You've grown. Less philosophically, though, you just don't remember what you were doing. And so given that, that set of categories, style is something that will help the latter two categories, so future you and other people, understand what you wrote. And so style is the unofficial set of rules of writing a program that make it easier for others to understand what you're trying to do and what your code actually does. Yeah, and I just want to highlight the fact here that the compiler doesn't care about style at all. These are unofficial rules in the sense that your code will work whether you have good style or bad style. But the difference is you may not understand what you were trying to do, and others who read your code might not be able to collaborate with you, or it might be much harder for them if you don't follow the accepted set of rules. The full set of rules is huge. Actually, I'll pull it up. So I know I said it is unofficial. Python, like the organization that created the language Python, actually does have a set of rules that they recommend for how you should use Python. There's tons of them here. Just really tons. I could scroll and scroll and scroll. I'm not going to teach them to you in this class, going through like every single rule, for two reasons. One is we're kind of learning things as we go, so it wouldn't help if I tried to get you to memorize all these rules right now anyway. You don't know a lot of these concepts yet, but you will by the end of the course. But two, the set of rules that we use varies from place to place. And so I could teach you this set of rules, but actually, like for example, at Google has its own set of rules that you should follow when you're writing Google code, which makes it easier for other Google engineers to read your code. Whether it's now, if they're reviewing your code, or in the future, if you go work at Google, you're an intern, you write some code, you leave, someone else will have to read your code and maintain it and keep making changes to it. And so that's why we have these sets of rules. So I'm going to give you, as we go in this course, some basic rules that almost everyone follows. And I will expect that you follow these rules in the code that you write. And in fact, later on in the course, we might start grading the style of your code and giving you feedback on the style. But otherwise, just watch the code that I write as I write code for this class and see if you can pattern match some of the things that I'm doing, even if I'm not explicitly telling you that it's an unofficial style rule that I am teaching you. So the first rule has to do with variables, and you might have noticed this already in my code. Almost everyone follows the rule that variable names must be snake case. What is snake case? Snake case means that the variable names are all lowercase and multiple words are separated by underscores. So for example, num underscore people, student underscore name, student age, is underscore raining. When you read these out loud, you don't have to say the underscore. So usually if I was, narrating this, I'd say num people or student name or student age. This is a important one. I really want to make sure that the code that you write looks this way. It's just easier to look at code that follows the same set of rules. And speaking of variable names, the variable names that you pick should be descriptive. And so not just a random letter, but not so descriptive that it's kind of overwhelming. So if you wanted to represent the number of bananas, X is a bad way to represent that. It doesn't describe at all what's happening. Capital num, capital bananas is not bad, but it doesn't follow the first rule. It's not snake case. The quantity of bananas, all separated by underscores, follows the naming of snake case, but that is way too descriptive. Like, it doesn't need to be that long. And fruits, like, it's banana, so why not call it something to do with bananas? So a good name here would be num underscore bananas or banana underscore count. And if you're curious, by the way, this num bananas that you see here that I wrote in, capital N, UM, capital B, bananas, that is called camel case. It's each word kind of in the name is capitalized and they're all put together, concatenated without underscores. And then the other thing I want you to know is the rule for comments. So use comments to describe what your code does in the cases where it's not obvious from the variable names and operators. This is useful to help people kind of scan your code and see what it's doing more quickly. It's also very useful to document any assumptions that are built into what you're doing. So if I just had num seats equals 145, you wouldn't know that the reason I have that there is because it's actually the number of seats in the auditorium in the computer science building. The comment is what tells you that. That's not something you want to build into the variable name because it's just too descriptive. Maybe you could call it auditorium num seats, but a comment lets you be more expressive and communicate to whoever's reading your code what this magic number is. Let's take a look at this all together. So put all this together. Take a minute, pause the video, and look at this code and see if you can figure out what it does. I'll wait 5 seconds before continuing, so go ahead and pause. Okay. Were you able to figure it out? Probably not. Maybe you were, and that's pretty great. But when I look at this code, I find it really confusing, and I write code all day long for my job. So let's see if following some of our style rules can help. So first, well-written code isn't always the shortest thing. It's better sometimes for clarity to pull out nested calculations that have some inherent meaning, that have some semantic value, into a variable that has a name that clearly communicates what this thing is. And so this number, floor divided by 10 to the third power, is actually the number of thousands in that number, in the input number. So now we can see a little clearer, we get the number of thousands, and that's what we mod 10. Okay, but what is this x? X is still very unclear. So we should probably pick a clear named variable for x. So here I updated my code. I have thousands digit non-zero equals num thousands mod 10. So maybe it's a little clearer now what this code does. So we're going to print out the thousands digit non-zero. Okay, it looks like this is a Boolean. We can see num thousands mod 10 not equal to 0. So it's going to print true or false. Is the thousands digit non-zero or not? We can figure that out kind of quickly by reading the code. But if we just add descriptive comments, it's even easier. So we can see we've taken an integer, we check if the thousands place is non-zero, and then we print that out to the user. And so much, much quicker to read the code. Future you will be happy. Other people working with you will be happy. I will be happy as your instructor when I grade your assignments. And so this is an example of code that follows good style practices. And if you just take a look, compare these two sets of code. Much easier to read, maintain, and collaborate on code that is well commented, that uses good variable names, that doesn't try to cram too many things into a single line. Okay, before we go into control flow, I also just wanted to take this code and show you. how it runs, just so you can see what it does. You'll notice, by the way, that I'm using repl.com. Right now, Mimir seems to be down, and so I'm using Replit. It's the same thing as Mimir. It's an ID that's in the cloud. It just doesn't have an auto grader built in, so we're not using it for this class. But if I go here and I run my code, Python 3.py, so let's say I give a number, just number 5. Run that, it'll print false. But if I give a bigger number, like the number 1000, and I hit enter, see we get true because the thousandths digit is non-zero. Whereas if I give a even bigger number, but I make sure that the thousandths digit is 0, so 0, 1, 1, 1. So you can see the thousandths digit here is 0, and I hit enter. Oops, I need to actually run my code. 7, 4, 6, 3, 0, 1, 1, and I hit enter. This prints false because the thousandths digit here is 0.